and welcome to the video lecture, Types of Ballistic Evidence. Let's get started. So you learned about ballistic evidence during Survey of Forensic Science. So I just want to do a short review of this information for this video lecture. In particular, I want to focus on how crime scene investigators categorize ballistic weapons using class and individualizable characteristics. Now, the first class is type of firearm, and that's a basic concept that many of you are probably familiar with because this is Texas after all. Handguns are weapons that can be fired with one hand. Handguns can be either revolvers, in which the bullet cartridges are held in a rotating cylinder, or semi-automatic pistols, where the bullet cartridges are held in a magazine and loaded sequentially into the pistol from the top. Rifles are longer weapons that are intended to be held with both hands while being fired from the shoulder, and there are 4 different types of rifles, and each one uses a different loading technique. There are also shotguns. Shotguns are longer weapons like rifles, but lack the rifling interior that I'm going to describe in just a minute. And there are other types of weapons that we won't cover in depth here because these are the most commonly encountered at crime scenes. Now, in addition to classifying firearms by the type of weapon, there are also class characteristics that can compare handgun to handgun, rifle to rifle, etc. Weapon caliber is defined as the diameter of the barrel from land to land. Lands are part of what is called a rifling pattern. During manufacturing, a series of grooves is cut into the inside of the weapon barrel. These grooves will help the bullet spin during the flight, and they're used to improve accuracy of the fired bullet. Now, the exact rifling will differ based on firearm brand and manufacturer. In weapons that contain rifling, a cartridge case is fired from the weapon. The cartridge case contains a primer, a powder, and the bullet. When the cartridge case is hit by the firing pin inside the weapon, the primer will spark, which in turn will ignite the powder, resulting in the expulsion of the bullet through the barrel of the weapon. The cartridge case itself remains within the weapon unless it's ejected either by hand or automatically ejected, depending on the type of weapon. Shotguns are a little bit unique. Most shotguns are not rifled, meaning they don't provide a spin to the projectiles within. Instead, shotguns usually contain a shell. Like cartridge casings, shells contain a primer and powder, but the primer and powder are packed in using a wad, which is typically cotton, and then loaded with smaller shot pellets. The pellets provide a wide dispersion of projectiles. Sometimes shotgun shells can be loaded with a single projectile called a slug instead of the pellets. Here's a comparison of a description of these 2 types of ammunition. Notice there are 2 different types of shotgun shells. The shotgun shell on the left contains shot, which is the small pellets, whereas the shotgun shell on the right contains a small slug, or single slug. Because there's no rifling on the shotgun barrel, though, slugs are difficult to aim accurately over large distances because that's where the spin comes into play. There are multiple characteristics of ammunition that can be used to include or exclude known firearms. Investigators can compare the type of bullet, the shape of the bullet, and the size of the bullet with visual examination. The location of the primer and the shape of the cartridge case rim are also class characteristics that can be used to exclude known firearms. In rim-fire cartridges, the primer is located on the side of the cartridge, and the firing pin hits the edge of the cartridge case. Like it sounds, center-fire cartridges contain primer in the center of the bullet, and they'll show a firing pin hit right there in the center of the casing. Now, ballistic analysis is typically comparison-based, meaning that it requires both a known and unknown firearm to analyze. Let's say that crime scene investigators find fired ammunition at a crime scene. To determine what type of weapon fired the ammunition, investigators will use class characteristics of the ammunition to determine what types of weapons could and could not have been the original source. Once they find a suspected weapon, they will then use a visual comparison process to compare fired ammunition from the weapon that they think is the known to the ammunition of the unknown origin that was collected at the crime scene. Fired ammunition is collected via bullet traps, like this water trap shown in the photograph, because they slow the bullet down and allow them to be collected by the investigator without damaging the markings or the sides of the fired ammunition. Once you've collected the fired bullets, you can compare the knowns and the unknowns visually using a comparison microscope. When examining cartridge casings, investigators can compare the marks made by the firing pin and the ejector. The photograph on this slide shows a comparison of two firing pin impressions. You can tell that this cartridge casing was center fire because there's an indentation in the middle from the firing pin. Some firing pins create square or oval shape impressions, and that can also be used as a class characteristic for comparison. On fired bullets, investigators will compare the markings along the side of the bullet called striations. Striations are formed in part by the manufacturing process, specifically the machinery that's used to create the lands and grooves inside the barrel. The most common rifling method involves a scraping of some form, and that leads to an individualizable marking that can be compared. The photograph here shows the striation marks inside a land impression on a known and unknown bullet. Like fingerprints, firearm comparisons have changed with technology. The Bureau of Alcohol, Tobacco, Firearms, and Explosives, or ATF, manages a database called the Integrated Ballistic Identification System. IBIS is designed to help forensic analysts store, search, and compare fired bullets and cartridge casings with other agencies across the United States. Also, like fingerprints, the system is used to help analysts find possible sources by producing a short list of similar samples, but the final comparison is always done by a forensic analyst. Now, there's a huge caution with ballistic evidence. Barrel markings are not permanent. The striations within a weapon barrel can be affected naturally over time by multiple things. It can be multiple firings, dust in the barrel, rust. Striations can also be affected when an object is inserted into the barrel of the weapon, and sometimes that's done on purpose to destroy the ballistic evidence. If the striations are substantially changed, it may not be possible to match a bullet to the correct firearm, even if there is technically a match. At best, a forensic analyst may only be able to state the weapon cannot be excluded as the origin of the bullet recovered. All right, well, this concludes that video lecture. Thanks for watching, everyone.